Okay, so we're going to start with the end. We're actually going to start here with turn-in. We're going to look at what you are, in fact, going to be submitting for project 1 and how it should work. We'll work backwards from there. But this is why this is video 0. We'll go into the details of the project itself in just a second. Okay, so here is a local machine that I'm on, running on a WSL on the Windows machine, so nothing terribly special. We'll show that this still also works on the department machines, which is where you're going to want to test it in just a second here. Okay, so let's say that you have produced some particular solution. Let's look at what we are requesting you, no matter what language you put it in, to wrap it up with, which is a makefile. Now, if you don't know what a makefile is, man is your friend, right? So make is a build utility. It's also declarative language, but I will show you a perfectly functional makefile. Again, you're free to ask any questions about this. The point of this exercise is not to learn make. The point of this exercise is to submit something that no matter what language you did it in, we can run, right? So that's how that's going to work. So let's take a look at what a makefile looks like. Okay, so here is a makefile. So this is declaring that, so makefile is a series of recipes and dependencies, right? So it's a dependency graph. So we're saying that these two targets here, clean and test, don't actually produce something called clean and test as the actual outputs, right? The rest of this target here is what's actually doing my compilation, right? You do not have to have that one if you're running this in Python. You can basically jump straight to here, but we'll go there in a second. So if you're doing Java, if you're doing C, C++, you're going to want to make sure that you have some set of source files that you're actually dependent on to produce your binary. And then you're going to issue some line here to actually compile it. Okay. Now, we know that the make test target by the project description is going to invoke your binary on an input called test.in, right? So what does make test need in order to run? Again, think recipes. Well, it needs a test.in. If it's not there, it should complain and not try to run. It needs some binary. We don't care what you called yours. You could call it project 1, project1.py, project1.pitterpatter. We don't really care, right? But whatever your dependencies are, this is a target. It has the dependencies, and then we'll invoke them. If you are running Python, make sure that you run the correct environment version of Python, and that'll be easy to figure out because we'll show you what's going on the machines we'll run on. Again, I apologize, my voice is still not 100%, but it's better than it was last night. So I'll record this in the interests of time. Hopefully I'm reasonably audible. I like to in any makefile have a clean target. Doesn't depend on anything, which just cleans up your mess. So if you have a binary output for something like C, C++, if you want to clean up all of the PYC files that would get generated if you're running Python, clean up the output file, right? In this case, since we told you you're supposed to produce an output called out.txt, right, from an input called test.in. Okay, so makefile, pretty straightforward. Let me just show you here. So what we will be running is literally just make test. Right now, if you note, right, test just runs it. But if you look around, there's no binary there. That's okay. We've got a rule to make a binary. Right, so make. We're gonna make clean first. It'll tell us there's nothing to do. But so if we make test, it's gonna first build the binary that it says it needs. Then it's gonna run it. Great. Look, there's an out.txt. You're not turning that in, right? You're just turning in the stuff that's going to generate that, right? So whatever you happen to need to actually to run, you're going to bundle it all up and send it in. And before you do that, you should bundle it up and from whatever machine developed it on and test it on one of the machines it would actually be tested on. So we'll show you that in just a second. Right, so here you can see, look, here was tested in. oops, text, right? So do what it's supposed to do. Now let's clean it up. Do clean up before you submit. We don't need all of your compiled binaries. We really actually don't want them. We are going to recompile it. Or at least we would prefer to, because then that means it's actually more likely to be system compatible when we run it. So yeah, just give us your source. Okay. How do you make the source? Well, you build a tarball. All right. So here, let me remove this. And so tar, if you're not familiar with tar, stands for tape archive. Yeah. So tar, create a zipped file. We're going to name it. Let's name it the same thing. Run.tgz. And we're just going to go put everything in there. Okay. So it'll recreate it. Okay. And then you would SCP this to a system departmental machine of your choice. Right. So, for instance, if we want to just go something like this, right? So SCP, name of file, your account, one of our Linux machines, and off it would go. But I'm going to just show you what testing should look like then on the other side. Okay. Okay. So here is I've already copied the file over, put it in a nice own little directory, just for ease of exposition. And let's untar it, right? How could you test that what you're about to turn in is actually going to, work? Well, you can't know that what exactly I'm going to test on, but you can at least test that the make invocation is going to work as expected. Right? So tar extract zipped file. And look, we've recreated the directory structure we had before. And we can check that it works on a departmental machine as opposed to just my particular WSL. And let's check. Right? So let's make test. Okay, so that seems to be taking an onerous amount of time. So let's see whether that's the VPN being silly or whether it's actually hung. Might actually be hung. Okay, let me pause here for just a second, but this is why you want to actually test. Right, so again, one of the things that you'll note about the departmental machines is that they're running some, how should we say, fairly old versions of C, C++, Red Hat libraries, etc. So if you are running on a sufficiently modern machine, you might have to set the language flag, say for C++, to use the right ancient version for compatibility. Okay, so let me just pause here for just a second and see why it's hung. Okay, so let me reshare the screen here. It just did have a little network hinkiness there, so sorry about that. Okay, but well, it wasn't supposed to hang, it was supposed to fail. Because while you saw that it worked just fine when I ran it on my local machine, this is actually a versioning issue that I wanted to point out. In that the machine I was developing on locally at home is newer in terms of all of its settings than the versions of Linux and so forth that the department is using, that we will in fact be using to test on. So you do need to actually look for things like this, right? So, I have an operator here where in my version of C++, with my version of the standard library, the erase function actually returns a new iterator, and the version that they're still running here, well, is a void function. So, go compatibility, right? So, yeah, you can see this is an ancient version of Oops. Right. Very old. So you should probably check some of these things, or you should rely on a newer compiler, right? So I think we don't have Clang here. Well, as I said, very old. So make sure that whatever version you're running, Python, this won't be as big of an issue. But even there, do make sure that you know that when you run Python, see, if you just run Python, it'll run Python 2.7.5. That's probably not what you want. You probably want Python 3, right? So much better. So do be aware. So I will, without giving away the show, again, just pause here for a second. And okay, so in the end, go in, make whatever changes you need to make so that it works on this particular version. May require a little bit of software archaeology. I do apologize for that. But I suspect, for instance, this was a one-line change, right? It'll be pretty clear about what does and doesn't work. But these are the machines we're going to grade it on. So this is only the only common standard that we can apply, right? Otherwise, we have somebody submitting C++ 17 code, other people using like a C++ standard from 1999. We'd have to figure out which one's going to work. Well, the answer is we're going to grade is the ones that are on the departmental machines. Okay, so did my little one-line change, fixed it, ran it, and now we've got text. Good times. Okay, so just make sure that whatever you submit actually builds and runs on the departmental machines. So a little bit of a belabored exercise for the 0th video without going into the project itself. But again, if you don't know what you're supposed to turn in, right, you don't know how it's supposed to work, you don't know what you should check, I want to make sure that you are all aware of how this is going to be evaluated before we go any further. Okay, now on with the rest of the show in subsequent videos.